Okay, next is question number 13. So in question number 13, it says a bicycle pedal is connected to a circular chain ring by a lever. Okay, a person of weight W stands on the pedal. So try to imagine. This is basically the figure you can see here. It's a bicycle pedal. So we can definitely you have uh, definitely you have ridden bicycle, right? So definitely you have seen around a around a ring, the chain is connected, right? So when you pedal it, the chain rotates around the what? Ring, chain ring. Okay. So the lever is at an angle theta to the horizontal as shown. So this is the figure. So part A here, it's asking to determine the moment of W about the pivot when theta is 24 degree. So W is what? The force that you are providing on the pedal. This is 580 Newton. The length of lever, it is what? 0.21 meter. Okay. So we need to find out the moment, right? So moment is what? Moment is equals to, let me write the formula that would help you to understand. Moment equals to Fx. So this x is a spatial quantity. It is not the distance or length. It is basically the perpendicular distance of the line of action of force. Line of action of force, it means, look, this is the line of action of force, W. Okay, so the perpendicular distance between the line of action of force to the pivot. So this x is basically this one. Okay, so we need to find out this x. The angle is known, so we can easily find out this x using what? Cos theta. So cos how much angle? 24 degree. 24 degree, it is equals to what? X over the hypotenuse. Hypotenuse is what? It's 0.21, right? 0.21, yeah, the length of the lever, 0.21. So x equals to 0.21 cos 24 degree. Okay, so moments. So moment, it is equals to what? Fx, right? So F is the weight, so 580. F is the force W. 580 times 0.21 cos 24 degree. That much Newton meter, right? So let's calculate it out. 580 times 0.21 times cos 24. So that gives 111.269 Newton meter. Fine. So we can write it to three significant figures as 111 Newton meter. That's it. That's what part A of question number 13 has asked for. Fine. Okay. Next is part B of question number 13. Okay. It says the chain ring exerts a force F on the chain as shown. Okay. As you pedal the ring, okay, it will try to rotate in the clockwise direction. Okay. So that's why it will exert a force of F Newton on the chain. Okay. So F is proportional to the moment of W about the pivot. The force F, it is dependent on the moment of W about the pivot. Okay. Explain how F changes as theta increases from 0 degree to 90 degree. You do not need to do any calculations. This is for 2 marks. Okay. Fine. So the force F, it is dependent on the moment of W. Okay. So since it is dependent on the moment of W, so at first consider if theta increases from 0 degree to 90 degree, how the moment of W will change, right? Okay, so if theta increases, look, we know that the line of action of force I have showed you earlier in part A also, this is a perpendicular distance, right? So we know that the moment of W, moment of the force W, it is basically the force W times what? Its perpendicular distance. If you say the length of the lever, this is x, so x cos theta, right? So that means if theta increases from 0 degree to 90 degree, look, W is constant, x is constant, but theta, it is increasing from 0 to 90 degree. So if theta increases from 0 to 90 degree, we know that the value of cos theta will decrease. The value of cos theta will decrease. Therefore, moment of W will decrease. Hence, the force F will also what? Decrease. Fine. So for 2 marks, what we can say at first? The first point is that as theta increases, as theta increases, okay, as theta increases, x cos theta, right? As theta increases, x cos theta decreases, right? The x cos theta is basically the perpendicular distance, the perpendicular distance between the line of action of W and the pivot what? Decreases, right? Decreases. So moments of what? W decreases, hence what? uh, F decreases. That's it. So moments of W decreases, therefore what? F decreases. So here you need to mention one thing. What you have to mention? It is what? The theta is increasing from 0 to 90 degree. That means the force F decreases from maximum. Maximum is what? Maximum the force can be W, right? The maximum force can be W. So, or you can say the maximum, hence F decreases from maximum. So maximum is how much? Do we know maximum is how much? Maximum is when it says proportional, so we don't know exactly what would be the maximum value. So just say maximum, from maximum to 0. Okay, so 0 when theta is basically, when theta is what? 90 degree. When theta will be 90 degree, only then the force F will be what? 0. Fine. So that's what part B of question number 13 has asked for. Fine.